Alright students, in this video we are looking to solve starter problems using exponential and logarithmic functions. And the specific one that we will be looking at today is called the continuous exponential growth. This is very similar to the one we used in the past, the compounded continuously interest formula that looked like this. It was A equals P times E to the RT. This one is very similar to that, with the exception that a couple variables are changed. So f of x equals A times E to the RT, or y equals A times E to the RT. Remember, the f of x is just another way to say y. A stands for the initial amount or initial population. Y stands for the amount at t time. So if we're looking for population at t time, that's going to be y. And if, again, t is always going to be your time. All right, so let's get into it and let's look at a problem where we can apply this. It's a started problem, and let's look at this one here. All right, so let's scroll down just a bit. All right, here we go. So it's a story problem. Jason wants to buy a new TV, and this TV he thinks will improve in quality. The price of the TV currently is $2,500, and based on the trend, he thinks this will increase by 4% each year. So let's come up with an equation first. Let's come up with an equation. So this is going to be several parts. Let's come up with an equation. So A is going to be the equation. So let's use this formula here. So the initial amount is 2,500 times E to the RT. Remember R, and I forgot to write this up here, R is going to be the rate at which something is growing, improving, or sometimes decaying, right? And that's going to be in decimal. So in this case it's 4%, so 0.04 to the t. All right, so this is going to be the equation that will allow us to find any data regarding this scenario. So if I want to know the price of the TV in 5 years, well, what would it be? So in 5 years, all I have to do is take 5, plug it into that equation. So y equals to 2,500 times e to the 0.04 to the 5, or times 5 up here. So plug that in your calculator. So 2,500 times e to the 0.04 times 5, and we get that in 5 years this TV is going to be worth about $3,053.51. All right. Another question could be, when will this TV cost, let's say, $6,000? All right. When will this TV cost $6,000? So now I'm actually looking for the time. I'm looking for t. Same idea, all right? So this is going to be my y right now. 6,000 equals the initial amount, $2,500 times e to the RT. Well, we know what the R is, and I am looking for t. So the way I do this is I divide everything by 2,500. When I divide that on the left side, I get about 2.4 equals e to the 0.04t. That's a t. and you can verify this. You can pause this video and verify that. Well, to get t by itself, that's what we're looking for. We're looking for t. Let's apply natural log to both sides. As long as you do that to both sides, you will be okay. All right. So apply the natural log to both sides, and we get that. Now, a reminder that the base here is e. So e to the natural log of 2.4 is equal to all that, e to the 0.04t. So we know that they're both e's, and both expressions are equal. So then I can say, oh, that means that this exponent is equal to that exponent. So natural log of 2.4 is equal to 0.04t. And to get t by itself, I simply divide by 0.04 on both sides. And when I do that, I get that t is about, give or take, 21.889. So that means that in about almost 22 years, this TV will be worth about $6,000. All right, and most of the problems that you guys will see in your practice problems will be in this same format. I hope this makes sense, guys. Let me know.